Once you have data ready to train a model, you will iterate several times to tune the model's hyperparameters in an attempt to get the best results. This can be a tedious process to do by hand. Fortunately, Amazon SageMaker provides a hyperparameter tuning job that you can use to remove the heavy lifting. Tuning can be a repetitive task, so it's worth learning the code to be able to do this. We'll also look at the console output once our job's running. Now before we get started, let's take a look at the data we're going to use to train our model. Once again, I'm using the wine quality dataset from UCI data repository. If we import that in, we'll do a little bit of pre-processing and then take a look at the data. The first column you can see is the quality column, and this is actually our target. You'll notice the code here actually creates a mapping. So we're mapping the actual quality values down to a number between 0 and 5. The rest of the columns are just various attributes of wine, citric acid, chlorides, alcohol level, that type of thing. Next up, we're going to split the data. We're going to use sklearn to split the data, and we're going to split the data into 3 different sets. We're going to take 80% for the training set and 10% each for the test and the validate set. We're going to make sure that we have a balanced data set by specifying the stratify for the quality column. Next up, we want to upload this data to S3 so we can actually use them in the model. And finally, we'll go create the estimator that we can use to then tune the model. There's nothing special about this estimator. It's actually the estimator we've borrowed from a previous demo. You'll notice that we're actually specifying hyperparameters here, but we're only specifying really the number class, which is how many classes for the model to try and determine. In this case, it's 6, which matches the number of different values for our quality column. Next up, we create the input channels. This is basically telling SageMaker where the data is. So we've got a training channel which points to the training data and a validate channel that points to the validation data. The validation data is used to calculate the metric which will be used to evaluate the model. Now we're going to create the hyperparameter tuning job. There's a couple of things to note here. First of all, this is the hyperparameters that we're actually going to choose. And you're probably wondering where we got these from. If you take a look into the documentation on tuning an XGBoost model, you'll see there's 2 important sections. The first one is the metrics that are computed by the XGBoost algorithm. When tuning the model, we have to choose one of these metrics as the objective to evaluate the model. Which objective you choose is really going to depend upon the type of machine learning problem you're trying to solve. Next up are the tunable XGBoost hyperparameters. Here's a list of the hyperparameters that you can tune, as well as some recommended ranges. But also note the hyperparameters that have the greatest effect on the XGBoost objective metrics are the alpha, the min child weight, subsample, ETA, and numRound. And this is why in our example, we've selected these hyperparameters to tune. The objective metric we're choosing is the validation M error, and we're going to try and minimize that. As reference, the M error is the multi-class classification rate calculated as the number of wrong cases divided by all cases. We need to specify the maximum number of jobs, in this case 40, and then how many parallel jobs we want to run. Since this is going to tune the model based upon the results of the previous job, leaving it as 1 is probably not a bad idea. If we run this, it's going to run up to 40 training jobs to try and find the best one. As you can imagine, this is going to take a little bit of time. So let's come back when that's complete. The job's almost complete, so let's switch across to the console. You can see our job's now complete, and it took around 2 hours to complete the 40 training jobs. If we click into the job, we can see all of the different training jobs that have been executed. Here's the last 10, but we can go change and view all 40. You can see the objective metric value changes between each of the models. Remember, this is the metric that the model is trying to get the best value for. We can find the best training job through the best training job tab. And this is the best training job here with the M error value of 0.28 or 28%. And here's the best hyperparameters that were used in this particular job. If we flip back to our notebook, we can do the same type of thing through a little bit of code. Here what we're going to do is query the hyperparameter tuning job analytics. And this should give us a data frame with all of the training job results in. To find out the best, we can actually go look for the best training job. And then if we want to create a model for that job, we can simply attach an estimator to the best training job. We could then use that to create a batch transformer or deploy an endpoint. That's it for this demo. We'll see you in the next one.